Hello and welcome. In this tutorial, we will implement a recursive texture division effect in Max. The idea of this video is to create an image that kind of looks like the visualization of a quad tree. I will put a link to a coding train tutorial on quad trees into the description so you can get a deeper understanding of what that actually means. But yeah, for this video, it's just about the look and not the actual data structure of a quad tree. We will achieve this look by repeatedly downsampling a texture. Well, actually, it's the other way around. So we're starting with a low resolution and then we'll increase the resolution on each step. But this will only be done on certain tiles, which then results in this quad tree look. Because if we're changing the resolution for all of our tiles or for all of our pixels, it will just like look as if we're changing the resolution of the whole picture. So we will find a way to decide where this effect will be applied and where it won't be applied. Okay, I got this idea from a touch designer tutorial by Paqueta12. I will also put the link to this video into the description, and I can really recommend all of the videos on his channel. Okay, so this video consists of 3 parts. In the first one, we will take a look at sampling textures and downsampling UV coordinates. In the second part, we will create our final texture UVs with the repeated division. And in the third part, we will also draw edges around the tiles that we create to make it a bit clearer. I will start with an input video, a jit.world object as our GL rendering context, and also a jit.p window so we can monitor what we're doing. Okay, starting with the first part, the downsampling of UV coordinates. I will start with a jit.gl.pix codebox object. We can just plug our input video in here. And then the output can go right into our jit.world. So looking at the downsampling of UV coordinates. So our UV coordinates are just our normalized coordinates. So if I do something like UV equals norm, and then I can set this to our output. And then also play this, so this texture gets banked. So we can now see that we have coordinates that range from 0 to 1 on the x-axis, represented by the red channel, and from 0 to 1 on the y-axis, represented by the green channel. And yeah, this of course changes with the resolution. So if we have a texture that is like 2 big pixels by 2 pixels, we'd also have 2 tiles here for each direction or for each coordinate. And this is essentially what I want to simulate. So for the downsampling, I will create a variable. I'm not sure what to call it. Let's just call it divisions. For now, let's say this is 2. And then we can apply this to our normalized coordinates. So what I mean by 2 is that I want to have 2 tiles in the x direction and 2 tiles in the y direction. So this ranges from 0 to 1. So this is these are floats ranging from 0 to 1. So if I multiply this by our divisions, then it will go from 0 to 2, or I don't know, if this is 4, it will go from 0 to 4. But you can see that it's kind of clamped here because we can't, so 1 is already the maximum. So when we have reached 1, it will just be the same color. Yeah, so now this reaches from 0 to 4. If we are then taking or using the floor function, this means that we're only taking the integer part. So here we have 0, then here we would have 1, 2, and 3. And as I said, 1 is already the maximum, so this is just the same color. So in order to get 4 tiles, we then of course have to divide this by 4 again, or whatever our divisions may be. So now we can see that if we're using a 4, we get 4 tiles here. If we're using 12, we get 12 in each direction. If we're using 2, we're getting 2 in each direction. So the number of divisions here gives us the exact number of tiles. So the idea now is to create input UV coordinates that will divide this unevenly. So not like 2 by 2, but maybe we want to divide this one again, and then within the first tile we want to divide this one again, and so on, to achieve this quadtree look. In order to do this, we can, you could either program something complicated in JavaScript that really creates this quadtree structure. But I'm using a different approach. I will use a matrix and kind of do a feedback operation and thereby achieve this repeated division. So what do I actually mean by this? Let's start with, I guess we can put this down here for now, as we don't need it. Okay, so coming to the second part, creating the UV textures, this repeated division thing. I will start with a matrix. Let's call this one feedback, or let's call it divisions. And because we need the x coordinate and the y coordinate, we have 2 planes. We'll set this to float 32. And then for now, let's say this is just 4 by 4. I think in order to illustrate what we're doing, it would be best to use this jit.cell block here. So set all to, then bang. So what I'm doing now, I'm setting each of our cells to the number 2. And what I want in the end is a repeated division of these numbers. So on the next iteration, this will be 4, then 8, 16, 32, and so on. In order to achieve this, I will use a jit.gen code box, put it in here. And then we can do something like, again, here we want to get these divisions. This will be our input 1, of course, because this is what we're getting in here. And then we also need a maximum number of divisions, because if you're always multiplying this by 2, it will blow up very quickly. So let's say max divisions. And this will be equal to the number of cells we have. Because if we're going in here with 4 by 4, the maximum number of divisions I can have, or I want to have, is 4. Because this will determine the size of our tiles. And if I have 4 by 4 tiles, the maximum size can be 1/4 of the whole thing. Yeah, I think this will make more sense once we're seeing what we're doing here. So then every time I bang this matrix, I want to apply this division. So I can say if our divisions are smaller than the maximum number of divisions, then we want to apply this operation. And what is the operation? We're just taking our divisions that we get as an input and we're multiplying them by 2. And then as an output 1 will have the number of divisions again. As I said, I want to have this kind of feedback loop, so I have to copy this matrix, put it down here, because what happens then is, okay, we're banging this matrix, then this operation will be applied, and then we're resetting the matrix after the operation has been applied. So let's see if this worked. So let's start with 1. Okay, we're sending 1 in. This will be multiplied by 2. Then we're getting 2 out. Then I'm banging it again. We're getting 4 out. Then I'm banging it again. Nothing will happen because we have reached our maximum. If we do something like 16 times 16, starting again with 2, banging it again, 4, 8, 16. I don't know, 128 by 128 will be the same thing, and we can divide it up until we reach 128. But now I want to turn this into UV coordinates that we can use in here. So in order to do this, let's maybe put our divisions at output 2. Putting this here. Okay, why is it not working anymore? Okay, probably because we also need output 1. Let's see. Output 1 is 0. Okay, now it's working again. Okay, but what I actually want to do is, so for output 2, I want to have this feedback loop, so setting the divisions, and for output 1, I want to output this UV coordinates. So in order to do this, let's first create our UV coordinates. So UV equals the number of cells divided by the total dimension. Or no, the current cell divided by the total dimensions. So if we have 128 by 128, then we have the first cell is 0 divided by this up until 128 divided by this, which will give us 1 then. So now we have our normalized coordinates between 0 and 1. We can already put this here, use another jit.p window to see the output of this. So yeah, I mean, can I do something? No. Yeah, essentially this one is the same as this one. 0 to 1 on the x-axis is the green channel, and 0 to 1 on the y-axis is the, I guess it's the red and the blue channel. But doesn't matter for now. Coming back to what I wanted to do. Yeah, what I want to do now is create these UV coordinates. So I can just essentially copy this thing here, put it down here, and then also use this. Yeah, and then you can see that we're using the divisions from the matrix to then create these UV coordinates. We can then already use these to sample this texture here. So we could say something like, okay. Don't want to run out of space here. Oh, and what I forgot to show you here is if we're using these divisions, then we can sample our input texture like this. So we can say in one, sample it by the UV textures would be the input video in a 2x2 grid, but we can also say we want to have it in a 16x16 grid, and this is how we would downsample this texture. Okay, so, but we can now get rid of these UV coordinates because we're getting the UV coordinates out of this one. So we can say UV equals just input 2. And then we need to turn this matrix into a texture. So we can just say jit.gl texture. I will just say full HD, depth 0, type float 32. Just for it to be more explicit, we can also make some space up here, and we can also use this for our input. So this is for our input texture, then I'm copying it for our UV coordinates, plug this in here. And then, so we also can get rid of the divisions because we're getting them from this one here. Yeah. Oh, that's interesting. It's -90 degrees. Ah, I see what's happening. So the way the planes of the... So here we're getting out a matrix and it's then interpreted as a texture, but the planes are flipped. So maybe we can do something like jit.unpack. So we want one output. We want to output 2 planes, and we want to have an offset of 1. Yeah, now it works again. And now yeah, maybe we should keep this here so we can see what's going on. But now you can see with the repeated division, we're starting with a very low resolution, getting higher and higher. Yeah, so far so boring, I'd say, because yeah, we could have done this in here and then just changing the division factor. But yeah, in order to really make use of this, I want to introduce a certain criteria that then decides, okay, are we dividing a cell or are we just leaving it as it is? And you could use different parameters for this. I will use the brightness of the input texture. So if the pixel of the input texture is very bright, I want to divide it. And if it's very dark, I don't want to divide it. Then we'll have certain regions with a very high resolution and certain regions with a very low resolution, and always in this kind of 2x2 grid structure. In order to do this, I will I mean, I guess we can get rid of this cell block here. I will make this a bit bigger so we have some more space. So yeah, how can we do this? Yeah, first we need the input texture. So yeah, I'm taking the output of this one here, and then I'm downsampling it. So now if we're just taking the output, this will be full HD. Then I will downsample this. So it has the same dimensions as this one, as the matrix we're using, 128 by 128. Depth 0. So now we downsample the texture here. Then we can, we need to turn this into a matrix, so we can use jit.gl async read. So this will turn our texture into a matrix. Then, okay, first of all, before we're turning it into a matrix, I only want to get the brightness of each pixel and not like the whole color information, because this is what we're actually going to use in here. So let's create another jit.gl.pix codebox object. Okay, this is getting a bit convoluted in here. Putting this here. Okay, so what do we actually need? We want to say output 1 equals RGB to HSL of input 1, and we only want the Z value of this. So now we're only getting the brightness. So now it's black and white. Can put this here. And then we can use our matrix, float 32, 128, 128. So now we can use this input to control whatever is happening here. Where to put this? Yeah, it's a bit convoluted, but I hope it's clear what's happening. Then we could call this input. So these are the divisions, and this will be like a control texture. So we can say, let's call this control divisions equals, now we have to sample this input with these UV coordinates again. So to do this, we can just say nearest from input 2, so from this input, using the UV coordinates, and we'll also use the bound mode clamp so it doesn't repeat on the edges. Then I have to do something like this. Yeah. So an error occurred. Where did it occur? Is this still the case, or was it from before? No, it's an older error. Now I can input this one in here. And now we have our control division. Maybe we can output this so we can see if it's working and what's going on. No, here. Okay, we're starting at 1. Then we're dividing it. So this is the control texture, dividing it. And at each step, like here, when it's 1 and it's very bright, we want the whole thing to divide. Then we're coming here. Now these are rather dark, these are light, so we would want this tile to divide into 4 again, this tile to divide into 4 again. Then on the next iteration, we would want this to divide, this should stay the same, this should stay the same, this should stay the same. So in order to do this, I want to introduce a parameter, call this one thresh, so our threshold. Let's set this to, I don't know, 0.25 or whatever for now. And then I want to apply this threshold and say, okay, we're only dividing if we haven't reached our maximum number of divisions, and also if this control division thing is bigger than our threshold. So now in theory, okay, first division, everything divided. Now we would only want this one to divide and this one to divide. So this one turn into 4, this one turn into 4. Yeah, that's exactly what happened. Now we have 4 here, these stayed the same. Looking at this one, we would want this one, this one, this one, this one, this one, and this one to divide again. Yeah, that's what happened here. Clicking it again, clicking it again. So you can see we have from the first division, only this tile stayed the same. Then we divided this again into 4. This one was divided into 4 and this one was divided into 4 again. And we can do this until all of them reached the number 128. And you can already see, so if I'm stopping this, that we have here, because it's very bright, many divisions have occurred. Here, only a few divisions have occurred, and then we get this nice quad tree looking structure where we have some parts of the image with a very high resolution and some parts of the image with a very low resolution. Yeah, we could also start with a different number here. So that the minimum number of divisions is also smaller. Yeah. Okay, so I think this concludes the second part of the tutorial. In the third part, I want to draw edges around our tiles here so it gets a bit clearer how this picture has been divided. Yeah, in order to do this, I will work in here again. So maybe we can say something like sampling, then say UV is input 2, color is input 1 sampled by UV, and output for now is just color. And then we can have another section down here and just call this edges. So in order to get the edges of each of those tiles, I want to look at each tile and its neighboring pixels. And if the neighboring pixel is the same, obviously no edge has occurred. But if the neighboring pixel differs from our current pixel, then we have an edge that we want to fill in black or white or whatever color we choose. Yeah, in order to look at the neighboring pixels, we first need the size of one pixel, which is 1 divided by our dimensions. I think I want to reassign or let's call this edge UV is our normalized coordinates, because we can't use the UVs we're getting from this one. We need the UVs for the whole yeah, for the texture that hasn't been downsampled. Then I want to take a look at the pixel to the right, which is nearest. Yeah. So I'm taking, instead of the color here, I'm taking the UV coordinates because there will be more of a difference, because if I'm taking the color, it could be the case that two neighboring tiles have the same color, but that won't be the case when we're using these UV coordinates. So, I mean, maybe this could also be a bit clearer. So this could be the visions UV, and this is then the edge UV, so we don't confuse it. So we're looking at the divisions UV. We're taking our edge UV and we're adding I'm again running out of space, so I will put this stuff here. Maybe I can just put this whole thing up here. Okay, sorry for this. Oh no. Sorry for this mess. Just a quick cleanup. So this can stay down here. Then, yeah, I guess we don't need this one anymore. And then we have some space here to look at our UV coordinates that we're getting out of this one. Yeah, then we can put this up here and I have a bit more space for our code box down here. And then maybe we can come from this side. Okay, I hope it's clear what's happening. So this one is going in here and in here. This one's going in here. Okay, moving on. Yeah, so we need a vector that's 1 pixel in. So if we want to look to the right, we need a vector that's 1 pixel in X direction and 0 pixels in Y direction. So we can just say this vector multiplied by 1 pixel. Then I'm just gonna copy this, and yeah, for the left it's essentially the same thing, but we're looking in -1 pixel direction. Then we have up, which means 0 in X direction, 1 in Y direction, and then we're looking down, which is the same thing, but with -1. Then we can say X. Oh, I just realized something. I only need up and right, because I can just look into one direction and then say, okay, we're looking at the absolute difference between the pixel that is above our pixel and the pixel we're looking at itself. So what that means is we're looking at, yeah, the current pixel and the pixel that's above it. But wait, this should be right because we're at the X direction. So let's take a look at this. Oh, that's very interesting. Let's say we're only taking the brightness of this RGB to HSL of X. And then we're just taking it if it is bigger than 0. Okay, let's start over. Okay, now it makes more sense. So we have the edges on the... Oh, actually it was right, because this is like the y direction is from top to bottom. So we can just leave it like that. And then for x, we can essentially do the same thing. But now we're using up. No, wait, this is y. I'm sorry. I think this is very confusing. Okay, and then I can say if I'm combining them, yeah, I get all of the edges. So starting, we have like, we're starting with 4, then some of them are getting divided, some of them are getting divided again, some of them are getting divided again, some of them are getting divided again. Perfect. So these are the edges. And now as an output, so maybe let's say edges equals x plus y and then we can say output equals color plus edges. Did I just make a mistake? So this one is color. Why am I not seeing this? UV is not defined. Is this current error? Variable UV is not defined. Where am I using UV? I'm using UV here. Of course, I changed the name of this variable. So now it should be working. Okay, now we have these white edges. I think it would look better if we have black edges. So minus this. Okay, this is maybe a bit too dark. So maybe let's multiply this by 0.5. Okay, I think this looks much nicer. Yeah, we can put this somewhere here so we have a better view. Okay, yeah, starting with this and dividing it. And then you can see, okay, here we have lots of divisions, here almost no divisions took place, and here we have more divisions. What we also could do, because as you can see, this picture is dynamic, so each division will only correspond to the frame, so the actual frame that we used to divide this. So what we could do is something like, I'll put this down here. So build something that will do constant divisions. So we could do something like, I don't know, setting a counter to 15 divisions, or yeah, let's try 15 divisions for now and say, okay, when this counter is at 0, I want to reset everything, and if it's not at 0, I want to keep dividing. And then we could use a qmetro to drive this. So now you can see that every 15 banks we're starting over, and we'll just keep on dividing this. This could also be much faster. I'm wondering, I mean, maybe I will regret this, but maybe we can handle this every frame. I'm not sure. Yeah, okay, seems to be possible. So now we're dividing this at every frame, but depending on the machine you're using, this might be too much for a computer to handle. Okay, what we also could do is, so now we're dividing by 2 and starting by 4. So we could also say we're dividing this by 3 and we're starting by 3. Then you can see that instead of having a 2 by 2, we're doing a division that's 3 by 3. We could maybe also do 5, but that's probably... Yeah, if you're using, so the bigger this number is, or the bigger this division number is, the smaller it gets on each iteration. So I really like starting with 4 or something and then dividing by 2. Okay. And of course, you could also use something else then. So now we're using the brightness of each pixel. We could also do it by color. This would be so the hue from huge saturation lightness. So now we're dividing by color. So I guess the redder a pixel is, the less likely it is that it's getting divided. We can also use the saturation of the pixel. Okay, the more saturated, the more divisions we have. But you could also use something that's a little more sophisticated. So you could look at neighboring pixels and take a look at, okay, is there a change in color? And if there's not a lot of change in color, you don't have to divide and then get some kind of a JPEG looking compression, I guess. What we could also do is, of course, changing this to smaller than. So the darker, the more divisions. Or we could, of course, also change the threshold from the outside. Yeah. But I think 2.5 actually looks pretty good. Okay, I think that's essentially it for this video. This is what I wanted to show you. I hope you found this useful, and thanks for watching.